Electricians, let's answer that licensing exam question I challenged you with recently from our book, A Comprehensive Guide, available in the TikTok shop. It reads, a 120 208 volt three-phase system feeds a detached building with a load of 24,960 volt amps using 1-gauge copper conductors. What is the maximum distance the feeder can be to not have a voltage drop of more than 5%? This is probably a journeyman's, if not a master's licensing exam question. We're not going to be using our code books. You can't find the answer in that, but I do cover this topic in chapters 4 and 2 of our book, A Comprehensive Guide. The formula that you need to know is voltage drop equals to kill over the circular mills of our conductor. However, this question specifies that it's not single phase, it is three-phase. Anytime you see three-phase, we're going to replace our 2 with 1.732. So let me change that. So voltage drop equals 1.732 times our K times our I times our L over the circular mills of our wire. However, when we look at this question, it's asking us what's the maximum distance. So what we need to do is solve for L. So we need to use basic algebra, which again we cover in chapter 2 of our book, so that you can take a formula like this and rearrange it so that it's actually solving for L rather than solving for our voltage drop. Okay, so what we need to do is we see that the numerator is being divided by our circular mills. So how do I get rid of that? So if it's being divided, we're going to multiply by that same circular mills to cancel it out. However, what you do on one side of the equation, you have to do on the other side to keep that statement, to keep that formula true. So I'm going to multiply by circular mills on this side as well. So I'm going to rewrite this so that it's circular mills times our voltage drop equals 1.732 times our K times our I times our L. Remember, we still need to get L by itself, and right now it's being multiplied by 1.732 and K and I. So what we need to do is divide by 1.732 and K and I so that it cancels out. But again, like I said earlier, what we do on one side of the equation, we have to do on the other side. So now I'm going to divide by 1.732 times our K times our I, and not by our L because we didn't do that. So now L is by itself. So rewriting this, it is circular mills times our voltage drop divided by 1.732 times K times I finally gives us the length. Okay, so now we have our proper formula to properly size this. So now I need to plug in what I know. Let's start with the circular mills of our wire. So in the question, it tells us that we're using 1-gauge copper conductors. It doesn't tell us the circular mills. So now we need to go to our code book, and we're going to go to chapter 9 and table 8, and that's going to give us the conductor properties. Here we are, chapter 9, table 8. On this left column, it gives us a wire size, so we're going to go down to 1, and then 2 columns over, we have our circular mills. So it's 83,690. Let me write that down. 83,690 times our voltage drop. What's our voltage drop? The question says we can't exceed 5% of our voltage. So how do we figure our 5% of our voltage? Our voltage is 208 volts, and we need to multiply that by 5%, which is the same thing as me writing 0.05. So getting my calculator, 208 times 0.05 gives me 10.4 volts. So I'm going to write 10.4. Now I need to divide by 1.732 times K. What is our K constant? Again, it's not in the code book. They expect you to know that. So for copper conductors, like our question says, we need to know that our K value is 12.9. If it was aluminum, it would be, I think it's 21.2. Hopefully I'm getting that right, but I do know it's 12.9 for our copper conductors. And now the ampacity. What is our ampacity here? The question actually doesn't tell us, but it does give us the volt amps, which is our power, our wattage, right? So we do know that P equals I times E, but in a three-phase, it's also times 1.732. We do know our P, which is 24,000, I'm dyslexic, let me get this right, 960 volt amps equals our I, our voltage is 208 times 1.732. So let me simplify this. I'm going to go 208 times 1.732. 208 times 1.732. And that gives me 360 0.256. Okay, so rewriting this, 24,960 equals I times, this is now simplified, 360.256. But again, I'm solving for I. I need to get the I in this voltage drop formula. So just like I did earlier, I'm going to divide, since it's being multiplied, I'm going to divide by 360.256, canceling that out. But what I do on this side of the equation, I have to do on the other. So divided by 360.256. So now let me take my volt amps, right? 24,960 divided by 360.256. And that's finally going to give me the power of 69.28 amps. So that's finally my I. Now I can finally plug that in to my voltage drop formula, 69.28, and that gives me the length. So now I can simplify, right? Let's start with the numerator, 83,690 multiplied by 10.4 gives me a numerator of 870. Hopefully you guys can see this. I haven't been looking. 870,376. So that's my numerator. Divided by, so let me get 1.732 multiplied by 12.9 multiplied by 69.28 gives me a denominator of 1,547.91. I always round to the hundredth in this case, and now we get our length. So now we can finally solve 870,376 divided by 1,547.91 gives me a length of 562 feet is my length. Looking at my options, 562 is exactly C. I am confident that the maximum distance this feeder can be to not exceed our 5% voltage drop is 562 feet. That is my answer. I'm confident. Comment down below if you learned something, if you have any suggestions of future videos you would like to see me teach or solve or whatever it is, comment down below. Hopefully you enjoyed this one, guys. We will see you on the next one.